Okay. So this is what it's all about.
Hokey pokey?
Um,
Oh, shit.
What you come to school for, right? How to read your gauges.
Oh,
pick
yes.
Temperature.
Do I need my
right?
gauges? They're in my car. Okay.
No, he said.
Okay, so in this mod, we're focusing on air conditioning, right? Okay. So,
And
air conditioning
shapes.
comes in all, many sizes
And
And
shapes.
shapes.
and shapes.
That's what she said.
Okay, so we're gonna talk about it. We know what that is, right?
Window AC unit.
Yes.
Yes, window AC unit. We've all seen them, right?
Yep.
Good. We've seen one of those?
Yep.
Oh, yes.
Portable ACs, yes.
Yep.
I'm waiting for a hunch, but
Yeah.
I don't have a window.
We've seen those?
Yep.
Mini splits, yes.
I wanna put one of those.
Oh, yeah, I see.
There's one back there. Yes. There's another one, multiple cassettes.
Oh.
Now we have what's called a PTAC unit.
P-Tech.
What's PTAC unit? You know what it stands for?
No. I know I just see them along hotels.
Package terminal air conditioner. A little different, right? Got quiet. You got quiet. There's another picture one there. And we have split systems, like the one in the back, right?
That's what I have in the house.
Got two sections, got an indoor section and an outdoor section. Split system, that's why they call it split. Connected by refrigerant lines. Refrigerant lines right there, connection right there, and then on this side too. That's what it looks like outside. I'm sure you've seen these, right? Okay. Split system.
I've never seen one of those in my life.
You never seen one of those?
What?
Never. Being sarcastic.
Okay.
In your home?
We also have package rooftop units. This is a package rooftop unit.
I think that's what I had.
It's gas and electric. Heating and air conditioning in the same, all in the same cabinet. Could be electric heat and electric cool. So it's still a package unit. Another one on the roof there. Oh, look,
Ooh, it's a
they put them on the
one.
ground. Yes, they can put them on the ground. And they do sometimes.
Ugly though.
We have commercial package units. These are commercials. See that? Got multiple units right there on the roof, see that? So this is a commercial building, right?
Correct.
Uh-huh. Okay, then we have a train car.
Yeah, we talked about that one.
What about that one? That's a train car. It's called a train car because,
Looks like a
It
train.
looks like
It
a
looks
train.
like a train.
yeah, it's big enough to be a train car, almost.
Almost.
What?
A what?
It looks more like a bus to me.
Yeah. There's the old
You're
one there.
wrong.
Is that a mobile?
That looks like a home.
It does.
You can walk inside of it.
What?
In fact, you have to walk inside and get the filters out
They're not big.
when you change filters. Yeah. We also have chillers. That's a chiller.
Yeah.
That's how a chiller works. We won't talk about chillers. Here, just know that they're there. You'll learn about chillers.
Just know their
Yeah.
existence.
Yeah. Most commercial buildings are gonna have chillers in them.
I don't know what that is. I don't know why you tell me about Applebee's right now, I'm trying to pay attention.
Chillers, if you have a chiller, you're gonna have one of these, more than likely, which is a cooling tower, which cools the water off, that cools the condenser. We also have boilers. That's a little bitty boiler. Steam boilers look like that. Okay, so that's enough of heating. You know, we're actually gonna focus on air conditioning. Oh, package chiller, it's a package chiller right there, it's on the ground or on the roof, air cooled. Okay, so, we're gonna focus on air conditioning. So what does that say? What does it say?
Oh,
These are some
residential air
facts, you
conditioning.
should know all these, right?
Yeah.
Yeah,
Yeah,
correct.
and some of you having to take pictures of this, which nobody ever thought of anyway.
Take a picture, Ray.
I made
No, he makes
Quickly.
copies of this slide.
Send it to me.
Okay,
Thank you.
oh, it's a little blurry,
Check it again.
okay.
I'll take this picture.
Oh, giving us a
Oh,
printout
no,
of
you
it?
can see it, I know, I was thinking just the one here.
Don't question my methods, Alex. My bad.
Okay, so air conditioning itself, some facts.
Fun.
He said some, not
There's
fun.
12,000 BTUs in a ton of air conditioning. Okay,
Damn right.
400 CFM% across the evaporator. What's CFM?
CFM
Cubic
and
feet.
cubic.
Per minute. Per minute.
Okay. There is a 20-degree delta T
Mm-hmm.
from the return to the supply air. Okay, you got that?
Yeah.
There is a 35-degree delta T from the return air to the low side saturation temperature. We'll get into that. Superheat is gonna run from 8 to 12,
12,
subcooling
10,
from 10 to 15 degrees. The condensing air temperature is 20 to 35 degrees above the ambient temperature. Okay? That make sense?
Yes.
Yeah.
Okay, so what we'll do is we'll look at a system. Look at that, and then we'll diagnose it, and we'll put the pressures in there and everything. Okay, are you guys ready for this?
Yeah, let's do
Are you
it.
focusing? Okay, so in this example, we have R22. Does everybody have the app?
Yes.
You download the app?
For the what?
Oh,
You need a
the
PC
The
calculator.
app?
They,
Oh.
The
they
app.
don't know.
I had no knowledge of
The app.
it. Yeah.
I got it.
download it.
Get
Yeah.
it?
Yeah, get
never
it,
had
what are you
knowledge
waiting
of
for?
that.
Like
Let's
right
go,
now.
What are you waiting
now?
for?
Come
Yeah,
on.
like
Today
right
I
now.
do.
Yet.
Let's go,
You're not working?
come on,
Come on, man.
come on, you got to prepare for work,
Yeah,
let's
calculator.
go.
Yeah, but.
PC
the app.
calculator.
My phone was like, you gotta use this.
Okay.
Why did they say R22?
So for R22.
Oh, there it is.
We'll look at the, chart.
You guys know what app to download?
No.
Why not?
You guys didn't tell us. PC calculator.
Oh, TT.
No.
That one
PC.
right up there,
Yeah.
Oh,
right here,
right.
come on, come on, here's
that one. Just put that in your, app.
Yeah, she said.
it. Is it
I
the
didn't say
ice store?
ass, I said app.
I never said he's an ass.
Yeah, but I know you thought. Sorry, Steve.
What do you?
He's recording, right?
He knows better to record our class, but he chooses to. Okay.
I think he does
Okay,
it for
so
liability purposes.
If we're looking at R22, and we have
Okay.
pressures and temperatures, we've got two temperatures right there, right?
Yeah.
Okay, now, if you open your book,
Okay.
on to page 37. 37. Page 1237, you there?
Yes.
When you get there, say amen.
Amen.
Oh, jeez. I'm like in church right now. Amen.
Okay,
Hallelujah.
all right, so, on paragraph 41, 3, it talks about temperature approach and temperature difference. Temperature approach and temperature difference, right? Okay, there is a difference. So we will go back to the slide so you don't get confused. The temperature approach is here. And the temperature difference is here. Okay, so what does it say right there in that paragraph?
Many technicians use the terms approach temperature or temperature split to describe the difference in temperature between heat exchange mediums. For example, the difference in temperature between the indoor coil and the return air for a central air conditioning system, 35 degrees Fahrenheit for standard air conditioning equipment. The condenser also has an approach or split temperature. These temperatures are used by the technicians to determine when a heat exchanger is functioning correctly. For example, when an air cooled condenser approach temperature begins to increase, it is a sign that the condenser is not condensing efficiently. This tells the technician that the coil is dirty or that there is not enough air passing through the coil. Over the coil.
Okay, so there's a term in there that we're gonna learn. We talked about delta T from the supply air to return air.
Mm-hmm.
Okay, so now we're gonna talk about a delta T from the return air to the low side saturation temperature. Okay, so if we go to our chart, what this is saying from the return air temperature to the low side saturation temperature, we can look at this diagram right here. And if this is the return air temperature of 90, then our coil temperature or our saturation temperature should be 35 degrees lower than that, right? You seeing that?
Yeah.
So what would that be?
55.
55, right? According to the book, it says there should be a 35 degree temperature difference from the return air to the surface temperature of the evaporator coil. Okay, so at 55 degrees, what do we got for R22? We look at our pressure temperature chart.
92.4.
So 55.
Are you sure?
I got 92.6. Yeah, there's a 0 feet.
Wait, are we talking about what we, return air, okay. I wasn't here the day that we did the chart thing, so I don't know how to read it.
95. Which one did you get?
Mine is at 0 feet altitude and it's 92.4.
That one there.
Mine's at 95.
So I went to R22,
R22
and then I see the PT chart, right? And then what we're looking
at
at.
55 degrees.
Oh, wait,
I think, yeah.
Yeah.
oh, wait, that's.
At 55 degrees, R22 is what pressure?
92.4.
No, it's 92.
And then
You did 55 and then.
okay, so when I.
92 PSI
G.
G. Okay,
Go to the-
everybody got that? Everybody on there? Everybody see that?
Wait,
Is that what we're looking
I
at?
have 95.
You might have a different altitude.
Yeah.
Yeah. 0.
Come on down to earth, Victor.
It says high altitude.
Yeah. Come on down to
It
earth.
has to be on what, sea
Yeah.
level?
Come down to the flatlands.
Right, 92.6.
Right. All right. So that's telling us what our pressure should be according to that temperature. Hello. That temperature inside the house is 90 degrees. That's telling us what we should be reading on our gauges. What?
No, I'm just,
And
my,
if we're not, what?
my app is saying something completely different, so I'm not too sure what's going on over here.
Sea level or?
Well,
Sea level, Victor.
It's
yeah,
not sea level?
What's your app?
yeah, come down to earth.
Get this app. Get the one we can have.
Get off your high horse and come on down to earth.
So Steve, if the.
It's an apple, okay? It's an apple.
Leave my app alone.
If the,
That's what she said.
G. What?
if it was lower than that, what was,
Lower than sea level?
yeah, if it's the
You
PSI.
can't get go much lower. Okay, so, have we got that? Everybody
Yeah.
follow that? Everybody follow the process we just did?
Yes, sir.
90-degree ambient temperature in the house. That's probably what the thermostat is saying. So we can determine on the refrigerant what we should be reading on our pressure gauges, right?
20-degree difference from the other side.
Right? Okay. So, with if it's 100 degrees or 110 degrees outside,
The temperature. You'll just enter the temperature. You don't need all.
You guys
Trying to
mix?
learn here, guys.
I'm trying to learn it too. Continue, Steve. I don't wanna feel lost.
if it's 110 degrees outside, what temperature, what surface temperature is that condenser coil?
90. 130. It's a 20-degree difference. It's either 90 or 130.
That's right there, 30 degrees over ambient,
Oh,
140.
140.
140. Okay, so that, because that's on the surface temperature, is the same thing as the saturation temperature. That means that our pressure is gonna equal 140 for R22, which is
338.
337.
337. 337. Okay? Everybody see that?
Mhm.
That how we did that? Yes. What's so funny?
This is awesome.
I'd like to
This
laugh.
is awesome.
Okay. So you wanna know what you're supposed to read on your gauges?
I asked.
That's what we need to read right there.
You have to figure it out. Cause no book is ever published that's gonna give you all the pressures and temperatures of what they should be. Okay, so this is up to you guys. To work it out, figure it out. Okay, so if we look at this system, we go further under this system, and we're taking the temperatures, we're also gonna have a supply air temperature. What is our supply air temperature? If we have a 20-degree temperature split,
70. Yeah, 20 degrees, 70.
70, so our supply air temperature is gonna be 70. Right? Got that? Okay, so, our condenser temperature is pretty much gonna be 140 out. It usually works out that way, so if you take the temperature of your condenser, air coming out of that condenser, it's usually 140. Because it's just right there, okay? The couple other readings we're gonna take here, we're gonna take what they call the suction line temperature and the liquid line temperature, and that's gonna give us our superheat, or we're gonna determine our superheat. So, if we have superheat, now let me tell you a little bit about superheat. Superheat is the temperature above the evaporator saturation temperature. The superheat is above that. Okay? By how much?
8 to 12 degrees.
On this one? How much?
10 to 15.
9.
9.
9.
Wow, it's also correct.
So super, you think of super, it's gonna be above. Where does Superman go?
To the
Up
sky.
and away.
Up in the sky, right? Up, super. Look, up in the sky. It's a bird, it's a plane. No, it's Superman. Able to leap tall buildings in a single bound. More powerful than a locomotive, faster than a speeding bullet. So think of super is up, right? If you think of subcooling,
Submarine.
submarine goes sub below, right? So
Like Superwoman when it's Superman.
subway,
Ooh,
submarine,
Subway sounds good.
subterranean, submersive,
Submissive.
submissive. Okay, so when we're gonna go to superheat subcooling, this is what we're gonna do. We're we're gonna go from this temperature, right? We're gonna go up or down? For superheat? Okay, so what's 9 and 55? What's 9 and 55?
64.
64. So we're gonna read 64 degrees right here on this section line. Isn't that amazing? Okay, what about our subcooling?
Subcooling is now 15, so it'll be 125.
125.
Yeah.
125. 125 degrees on the liquid line. Now, in order for you to understand why subcooling superheat is important, superheat, if this temperature right here contains liquid and vapor, okay? Because that's where it's changing state. That's where the refrigerant is changing from a vapor or a liquid to a vapor, right? Okay, so we wanna make sure that in the suction line, before it gets to the compressor, we wanna make sure that it's 100% vapor. Okay, so if we had 55 degrees right here, what's that telling us?
There's 55 degrees right there.
Everybody all at once, in unison this time.
What is it telling us?
There's still liquid in this. And that's bad.
Well, I still didn't get it, but that's all right.
Real bad.
So what does that mean if we got 55 degrees right there?
Liquid in the,
There's liquid right
There's
there.
still liquid in there.
Yeah, and we can't have liquid in the compressor because the compressor will only compress liquid once. And then it's not gonna do anything.
I wasn't even close.
It is a vapor pump. Okay? So no liquid anywhere around that compressor, none whatsoever. So we're gonna ensure that there's superheat, so we're gonna put superheat, and we're gonna add superheat to ensure that there's only vapor going to that compressor. Okay? This is also gonna change quite a bit on the charge. If the charge is a little bit over or a little bit under, we're gonna see that on the superheat. That's the first thing that's gonna move around is that superheat, so we're gonna take that temperature. And the same thing on the subcooling, we wanna ensure what goes in this line?
Liquid.
Liquid, that's why they call it a
Liquid
liquid
line.
line.
I would have never guessed.
Yeah, okay. So 140 degrees, what's happening with the refrigerant at 140 degrees here?
Evaporating.
What is it? What is it? What's happening?
Vapor.
What?
It's evaporating.
No, no, it's not evaporating.
Heat it up.
No, what does it do in a condenser?
Condenser.
Condensing.
Okay, does that mean evaporating?
No,
No.
it's condensing.
It means condensing.
What does it mean?
Okay, so it's condensing, it's turning into liquid. What did it do over here?
Turn into a vapor.
It turned into a vapor, so over here, it's gonna turn into a liquid. So it's gonna be vapor going through here, it's gonna make that transition at that temperature and that pressure until it comes out of that liquid line and it cools off some more, which meaning subcooling. So we can see the subcooling right here because we're now, our liquid line is no longer 140. Our liquid line is dropped below the saturation temperature to 125. See that? So that's making sure that there's only liquid in this line. Because we need 100% liquid to go to the metering device.
What happens at the metering device?
Yeah, okay? So are we, well, I know this probably isn't very clear to you. So you guys, I'll focus on you guys here,
No, we get it.
because these guys already got it.
Supposedly.
Supposedly.
Yeah.
Okay, so that's why superheat and subcooling is important on on our air conditioning systems and our refrigeration systems too, okay? We'll get more into this, you're gonna go in depth on this in advance. So I'm just trying to break you in on it, so you get a little bit of it beforehand. So if you notice, of all the readings that we took, what are they?
Different.
Are they, what are they? Pressure, temperature, what?
Temperature on the thermometers.
All temperature. So, the pressure, I don't care what the pressure is, and you shouldn't care either. No, it's no big deal. Pressure doesn't mean nothing
That's what she said.
to me, because the pressure's gonna change. Well, what I'm concerned about is that temperature right there. That pressure's gonna tell me what that temperature is, so the pressure gauges are there just to give us the temperature.
Wow.
That's all they're for, so it's no big deal, it's no big deal, right?
That's what you told us the day
It's
you
for
got our.
temperature. That's what we're trying to find out. Why are we concerned with temperature?
Cause it's.
That's our whole business.
Yeah, that's how the AC works, cause of the temperature.
Yeah.
Temperature technician.
Temperature,
we're
yeah,
temperature
technically we
engineers.
have a temperature technician.
Not technician, we're engineers, temperature engineers.
Oh,
Okay.
engineering
So,
and temperature.
if you also notice that we've taken a lot of readings on this system to find out exactly what's going on, alright? So we're checking a system that's normally operating normal. Okay, so you have to understand how the system works normally in order for you to troubleshoot any problems that it has when it's abnormal, right? So we got a temperature here, here, yeah, there. We're taking a lot of readings. And the reason why we do that is because it's gonna give us a better idea of what's happening inside that system. So at 125, I know that there's 100% liquid in that line. That's telling me there's 100% liquid in there without having to see inside of it, because you can't see it because it's copper, you can't see through copper. Same thing with the suction line. That temperature is telling me that is 100% vapor. Okay? It's also telling me if the difference between these two temperatures is the superheat, it's also telling me what's going on in the system. Whether it should be, if it should be 9 degrees and if it's 30 degrees, I know something's wrong, something's not right. Or if it should be 9 degrees and it's 3 degrees difference, I know there's something wrong. Okay, so this is where we're gonna check and we'll find out exactly what's happening with that system. We have to do this. Let me ask you something, when you go to the doctor, anybody been to the doctor?
Never
Anybody
in
go to
my
the
life.
doctor? Never?
Never, sorry.
Huh? Yeah, yeah.
Yeah, here it is.
How many readings do they take?
Never had one.
How many readings do they take?
One.
Like
One.
Well, some of that.
One. Okay, they take the temperature.
Yeah.
Okay, and then they say, oh, you got, cancer of the, yeah, that makes sense, huh? Right? Okay, what's the doctor gonna do? He's gonna take your temperature, he's gonna look in your ears, he's gonna look in your mouth, he's gonna check your blood pressure, right?
You're gonna stop there.
The more readings he takes, the better he understands what's happening in your body, right? We're doing the same thing. We're doing exactly the same thing. We're taking as many readings as we need to find out exactly what's going on with that system, so you can say we're doctors.
I don't
We're
think,
doctors.
I don't think doctors would like to say that.
I don't care what they, I don't care.
Shouldn't bust out deep.
We're taking more readings on our system than a doctor takes on you. Whoa, whoa.
My lord.
You don't consider yourself a doctor? Okay, you will.
Food for thought.
Yeah, okay. So are we ready for another one?
Yeah.
Do it.
Clear the smart board.
Now, do this now.
Mark board is all clear.
Okay.
Okay, so if we do this,
Okay.
we have a refrigerant of R407C, okay? Same situation, we got 80-degree return air in the house and 100-degree ambient outside temperature. So according to this, we're looking at 25 degrees over ambient temperature for the condensing, and we're looking at, well, we obviously know what that is, right? What our
45?
approach and our temperature, difference should
If
be,
it's 80, it's different than
Right.
35. 45,
I don't like this.
45. 45.
yeah.
How'd you get 45?
Subtract.
Oh, I had it.
45, right? Just think of it this way. This will help you remember. That evaporator in the air duct, that's in the airstream, has to be colder than the inside of the house in order for the temperature to drop, right? Right? If it was hotter than 80 degrees, it'd be a heater, right?
Right.
Yeah,
Okay,
so,
we got that?
yeah, so the pressure should be 70.
We haven't even looked at our phones yet. So what's our supply air supposed to be? Supply air temperature, what should that be?
20 degrees difference?
Different? So what?
Oh, did I say 25 over ambient?
60.
Where are you getting 60? Is it 20 degree difference or 25?
20.
It's 20.
Okay, so 80,
Our supply air
120.
How'd you get 45?
from the temperature approach.
Oh. 150.
He gave it. Is that right? 35.
65?
Because 80 minus 20 is 60.
Come on.
60.
Is it warmer than the ambient inside temperature? Or is it colder than the inside temperature?
Oh,
So 20 degree difference is what?
60.
Okay. Why are we saying 65?
He was saying 65.
Well, cause you didn't write 60, so it was wrong.
Okay. So how'd we get this temperature?
Oh,
By the, evaporator
what?
Yes, that's the
Sure, yeah.
evaporator. How'd we get that temperature on the evaporator?
on the,
So cool.
Delta T from the returner to the low side.
Yes, good job, Victor.
What are the things you need to know, and what are the things you have to remember? When you're working on air conditioning, you always have to remember that.
I know, but.
You're not gonna go to the book on this, it's gonna be automatic.
Wait,
Yeah, we haven't put the.
wait, how'd you get it?
How'd you get it?
Yeah, we put the pressure.
Hello? How'd you get it? How'd you get it?
It's 35 degrees difference from.
Oh,
from
35.
saturation.
oh, from the
Okay.
page.
The difference between the return air and the surface temperature of the evaporator.
Since it's a upward.
Okay, surface temperature of that evaporator is pretty much the same as the pressure, because that's when it's all happening. That's when the refrigeration is changing states, right?
Okay,
And then on the other side would be your
Okay, so we'll move over here to, it says 25 over ambient. What's our ambient temperature?
125?
Our ambient temperature 125?
Yeah.
Yeah.
No, our ambient temperature is 100. So what's our temperature of our condenser?
Oh, 125.
So that's 125. Right? Got that?
Correct.
Okay. So as far as our pressures are concerned, what pressure should we be reading on our gauges under this condition?
70.
Low side pressure is
70 PSIG. 70.6.
I don't think so, Tim.
I got 118.
For 407C?
407? Yeah. I think so. 70?
Yeah,
Yeah, 70.6.
or 70.7.
71, okay, we'll round up.
Okay. All right, so what about our high side pressures? At 125,
319.
319.
I'll put it under quickly.
Okay,
Oh, this side's bigger.
are we good so far?
Oh, that's about good.
Yeah. Does everybody get it? You get it right there? Josh? No?
Ray?
I think so, well,
I think I told you backwards.
so I can't, oh, yeah, because now, I'm
The
figuring it out.
evaporator, it's vapor on that side, so you put it,
Oh,
this
no.
one's a blend.
Oh, I told you, yeah, I told you, right. I was
Okay.
doing it backwards.
Okay,
That's what I was.
so on the chart, and especially on this refrigerant, on the 400 series refrigerants, we're talking about that's 2 or 3 different refrigerants in that 407C. So what's happening in the refrigerant is it's fractionating and it's changing temperature, or it's changing pressure and temperature at different rates. So if it's 45 degrees here, then it's not really 71 here. Because the components inside this refrigerant are boiling off at different temperatures.
Mm-hmm.
So that's what they call fractionization. So as a refrigerant fractionates, we have what they call a temperature glide. Temperature glide. Okay, so the temperature glide, we're gonna determine if on your app it says vapor pressure and liquid pressure, right?
Yes.
Okay, so on the low side, we're gonna take the vapor temperature, and we're gonna use the vapor pressure,
Right.
so on the low side. So on the high side, where we're checking, it's gonna be on the liquid side, so that's gonna be the liquid pressure. So we're gonna figure out subcooling with liquid pressure, and we're gonna figure out superheat with, vapor pressure. Okay?
Okay.
Okay, so what's our vapor pressure on that? What's our vapor pressure for 45? 71. What's our liquid pressure for 25? 125.
319.
319? Okay. Oh, we're using the right charts.
Yes.
Okay. Okay, so if we're looking at 14 degrees subcooling, what temperature are we looking at are our thermometer down here on our liquid line? What?
Yeah, 111.
111?
I got 2, 111. Do I have a 3?
Yeah,
Three,
Alex,
111?
Alex third in it.
3?
I concur.
Okay. Sold. Okay, so we should be seeing 111 degrees on our liquid line. What about our suction line now?
55?
We got what, 10 degrees superheat?
Yeah. 55.
55. 55. 45 plus 10 equals 55, right? Got that?
Yes.
Ooh. 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 You excited about that? I'm excited about that.
So what goes on the
I
box
like,
on the
I
far
like
right?
the looks that everybody got on their face, like.
We got that, look.
Yeah.
It's like the
That's the look we
air
got
brake.
on.
Almost everybody got
Let's
it.
see.
The good news is, we're gonna go over this in 2 mods. When we go to mod 2, we're gonna talk a little bit about that, and we're gonna have a slant towards refrigeration.
I won't be here.
No, but you've already been through mod 2.
Yes.
So, that's why you're understanding it, and these other guys are going, what?
Yeah.
Slow down, wait a minute.
Damn big.
But you were like
So
that
can I come back for that mod?
yeah,
I
You
probably
were like
understand
that,
more than
though.
you guys.
in mod two. You were going, I don't know, what? You were
See, this
doing
is
that.
easier to
Now
understand.
Now you got, oh
That's
man, I
exactly what
understand this,
said.
I get this, so you get a little bit of it. And I'll tell you a secret, you guys want a secret?
Always.
Oh,
Tell us a secret.
Okay, if you understand it, that's fine, that's great. If you're not quite getting it, that's okay. Because this is, we're gonna repeat this stuff all throughout this whole program. I just happen to put it, a little bit of it in the early mods to keep you guys excited about what you're gonna learn, right?
I'm fucking
So
stoked.
if you get this 100%, that's great. If you still don't get it,
Take a selfie.
we'll figure it
it's
out.
okay, you're gonna get it. One way or the other, it will start making sense to you. Whoa.
Mine.
Steve, she's back here taking pictures.
So, Steve,
Okay, you wanna do another one?
no, Steve, I got a question.
Huh?
I got a
Try
question.
to speak it.
What?
My question is,
Weird question.
if
Take a selfie with him.
we're getting all those, temperatures and it's not lining up with the, pressures of the gauges, then what does that mean?
That means you got a problem.
So I said, if it's too high, what?
Yeah, you got a problem.
What kind of problems?
You got a problem.
Is it leaking or is it?
I don't know.
Does it need
Why are you asking
refrigerant?
me? Why are you asking me?
You'll
You
know.
wanna go to advance.
You're the
You'll find
teacher.
out, you'll find out in advance.
You don't wanna tell me,
I don't wanna confuse anybody
He
else.
doesn't wanna ruin it.
Everybody's already confused.
but I get
Stop
it,
tilting
Steve.
your head.
That's a parking lot
Take off
question.
the filter.
There, I don't do filters, that's why.
That's a parking lot question.
I don't do filters.
Huh?
Do you chase the lighting?
Yeah.
I think I did.
You gotta understand, you gotta understand the system and how it's supposed to work. You gotta understand
My
that,
eyes are all dark.
otherwise you're not gonna see what's happening. It's not-
Can we get the worksheet?
Okay, so here's what you're gonna do. Check this out. I know you guys are gonna do this. You're gonna go to a system and you're gonna put your gauges on before you do anything, right?
No, cause
we're
you're
gonna put our
teaching us
thermometer
not to.
Yeah, you're just gonna stick your gauges on there. Oh, look, I got some pressures.
No.
Okay. But how are you supposed to know what the pressures are supposed to be? Until you figure things out, until you start taking some other readings. So, there you go, you put your gauges on there. Okay, I got these pressures, whoa! And you're all excited because you got pressures now, you got pressures on your, I got pressures!
Yeah.
And the customer's standing there watching you. What do you see? I got pressures. Okay, what do they mean? Well, I don't know, I'll let you know in a minute. What's the temperature inside?
That's a great question.
Go find out.
What's the temperature of the evaporator core?
Check it.
We don't know yet.
Yeah, you do.
Oh, you zoom.
68,
What is it?
one,
What is it?
17,
No one said, what are you doing?
oh wait.
I don't know what you
It's
do.
39, it's 40.
68,
It's 40,
no,
Steve.
wrong, 68.
40?
40.
It's 40 degrees, so we know that that coil is 40 degrees at 68 pounds per square inch gauge, right? We know that because of this pressure, right?
124 on the other side.
Okay, so what's our temperature inside the house?
In the house.
Would be
35 degree difference, so it'd be 75.
So our return air is 75?
Yeah.
Mhm.
We know that because of 35 degree approach.
Yep.
Okay, and that's gonna mean that our supply air temperature is what?
Should be
55. 55. So we actually can figure out what we're doing by our pressures, right?
Yeah.
Okay, so this side right here is 275 is what? 130?
124.
124?
Yep.
124 degrees. Okay, and assuming we got 25 degrees over ambient,
99.
That is an awful picture, Marco.
It's 89,
so it's 89?
I believe so.
Double check.
89 degrees
Yeah,
or 99?
89.
99.
89.
No, it's 25-degree difference.
Oh,
Yeah.
shit. Then my 99's right.
99.
I was
So
like,
it's 99 degrees.
Alex.
You don't have to figure all that to figure out what the temperature is on the outside, because you're gonna have a thermometer right there in your hand.
Right.
So you'll be able to tell exactly what's supposed to go in. And then you're also gonna see what your pressure and your temperature of your coil is, and whether or not you have subcooling. So on this, we're having 17 degrees subcooling. That's pretty good. That's good subcooling. So what temperature are we gonna see when we strap our thermometer on that?
107.
107?
107. We got two 107. You got three?
Fuck it, I'll take it, number 3.
Three.
107.
Sold. 107.
I don't think our vote counts.
Okay.
It should.
What about our super?
52.
Can't vote for the kid.
You say 52.
He said he can't vote for the kitchen.
You got it? You understand it now?
I get it.
Want another one?
Yeah, do it. That was fucking hilarious.
Okay. Well, we got another 401C, huh?
Really?
Another 401.
407C, right?
407, yeah. 401. You're paying attention, huh?
Trying to return.
Okay. So we know what our temperature should be at the saturation point, right?
Yeah.
Because you did it again, you just went up there and put your gauges on there, and, oh, I got pressures.
Mm-hmm.
What do they mean?
So it's gonna be 48.
48 or 44?
48.
48.
What is it?
Oh, I didn't change that.
48 degrees.
Yeah, 48.
Yeah.
Yeah, 48. 48 degrees on that coil, and the high side is what?
The high side is
132. I think.
132?
Yeah.
Okay, so we're condensing at 132 degrees. Right? So from that point, we can go
35 degrees.
anywhere, right? So do we know what our return air temperature is?
83.
Or should be? What?
83.
8? 83? 3.
83.
Yeah.
83.
Yes.
8. So we're gonna check it right at the unit, but we know that we should have 83 degrees, so. If we don't have 83, then we got a problem. Got something going on, right?
63.
Source applied air is what?
63.
63. Okay,
You get it, Felipe?
Nope. Come on, dudes, get it together.
no?
Okay, so we got
Nope.
48 by putting the pressure into the PT chart,
That's that.
and then there's a 35-degree difference
That one, yeah.
from return air to the low side saturation temp. So that's how we got the 83. You get the 63, it's a 20-degree difference from the return air to the supply air.
Yep. Okay. If you're gonna go check a unit out, let's check it out. Check it out. Check it out. Before we get our subcooling superheat on this one. Yeah, how about that?
Oh,
How about that?
Okay.
Okay.
Don't tell me the wrong one, that's one.
We'll go back to that. Okay, you're gonna check the unit out. It could be working fine. Okay? It could be okay. You're out there looking at it to make sure it's okay because you're doing maintenance. Could be a bunch of commercial units all lined up on the roof, let's say. Okay, so here's what you're gonna do.
35-degree difference.
Here's what you're gonna do.
What are we gonna do?
we got 82 degrees in the building, right? So we're looking for 62. So if we get 62, what do? As far as we go,
Yeah, it's good.
because you got 20 degrees. It's doing what that unit is doing what the manufacturer designed it to
It's
do.
supposed to do.
So a lot of times, if you don't get this, suppose you're getting something less. Okay, so suppose we're getting, I don't know, 69 degrees and 82, what is that? What's the
That's,
difference?
13.
Too hot.
Huh? 32? 13?
Yeah, 13,
Okay, if we got 13 degrees, we're supposed to have 20, right?
yeah.
So now we can go further and we can start checking some other stuff. But when I did service out in the field and I was servicing a bunch of units, instead of putting my gauges on every single one of them,
You just check the temperature.
I checked the temperature split. That delta T. If I got 20 degrees, I know that the refrigeration side is running fine. Perfect. So then I can spend the time looking at the electrical connections and stuff like that. So a lot of times the brokers or the management companies that call us say, well, we're gonna send a chart out for you, so I want, when you check your units out, we want the pressures on every single unit. And we want to log them and write them down on our checkoff sheet. And, we told them we're not gonna do that. Because if we've got 20 degrees temperature difference, there's no reason to check the pressures and check the refrigerant levels, because they're perfect. As you start losing refrigerant, if your refrigerant level goes down, the first thing that's gonna show up is your temperature split. First thing that's gonna show up is your superheat and subcooling. But if you're taking the temperature split, that's gonna be pretty obvious that you're not in your refrigerant charge, maybe suspect. Okay. Got that so far? Yes?
Yeah, yeah, good.
Okay, where we at?
For exemption.
What do we have? I read. You had what? 48,
48.
83, 63, and 132,
Yep.
and ambient temperature is 99?
Yep.
Yeah,
No.
wait,
Oh.
No.
32.
Over ambient, 35 over ambient,
97.
Yes.
97, 90. This is gonna vary quite a bit. This is a condenser temperature, that's gonna, that approach on the condenser side is gonna vary depending on the year and the efficiency of that unit. Okay, it could be anywhere from 20 degrees to 35 degrees. There's no way of knowing exactly what it's supposed to be because of the energy efficiency, and some units are more efficient than others, so they're gonna have better subcooling, so the condensers are a little bit bigger, so that throws off this delta T here. So we don't go by that anymore. Years ago, what we would do is we would add 35 degrees to the ambient on every single air conditioner, and we'd be right in where we're supposed to be. But since they started making high efficiency units, they changed the size of that condenser coil, and now it's lowered the pressure and lowered the temperature. So now we have different subcoolings for different units. Okay, so a unit that is over 40 years old, you can still go 35 degrees over ambient. But you gotta know that that unit's over 30 years old. Okay. This could be a unit that's over 40 years old, 45 years old. Because 407 is a replacement refrigerant for R22. So you could have 35 degrees over that ambient if it's an old unit. Okay. But what we found out is since we can't go by the condenser high side and just add 35 and figure out what our high side pressure is anymore, we can't do that anymore, it's just not possible with new high efficiency units. The only thing that didn't change is the indoor coil, which means what didn't change is comfort. Human comfort has not changed. So we're still gonna be comfortable at 75 degrees and 50% humidity, right? So in order to maintain that, this has gotta be consistent. So your split's gotta be consistent and your approach has gotta be consistent. So now we can look at the below side of the system and find out what our charge, if our charge is correct. On older units and newer units. Yeah. Yeah, we used to do this all the time, years ago, with just the high side. We had 35 degrees to the high side, and that would give us our pressure. You do it by the book, but you can't do it nowadays. Because they've started at higher efficiency units. Okay, so for, subcooling, what should we read on our section line?
Degree difference.
124.
124, got two.
Yeah.
124.
124. And our superheat
20 degree difference.
Is
8 degrees, no, 20 degrees?
68.
so yeah, 68.
68. Okay. How about that? How about that?
I think we got it.
That's you outside.
How about
How
that?
How about that?
You got it? You guys understand now?
Yep.
Yeah.
You want a worksheet? You said something about a worksheet?
Yeah, I'll take a worksheet.
You wanted, he said he wanted a worksheet.
That's fine, we'll just kill
It just so happens I have one right here.
What? How surprising.
What are the odds?
What? Yeah.
Wow.
Wishes do come true.